Freemans, let's do some more Anki cards. We'll jump right into it with Chem Chapter 10. Strong acids and bases have weak conjugates. Or very weak conjugates, which they called negligible for some reason. A Lewis base is the Lewis acids and Lewis base, Arrhenius acid, Arrhenius bases, and Bronsted. Lewis bases are things that donate protons or donate electrons. Lewis is the electron, so they're electron donators. POH is negative log of concentration of OH minus. Nitro acid, we have NO2 minus, which is nitrite, and we have NO3 minus, which is nitrate. And the acid form is nitrous acid, nitric acid. Indicators are compounds that change color during a pH change, and they're used to indicate when a titration is completed. How does one convert pH to P? It's POH. pH plus POH equals 14. What changes to an acid will make it stronger? You can stabilize the acid, adding more like Cl groups, for example, to stabilize the conjugate base, because the more stable the conjugate base is, the stronger the acid will be. Autoionization refers to the autoionization of water, where water will react with itself to form H plus and OH minus. The autoionization constant Kw equals 1 times 10 to negative 14. Strong acids are... What does it mean to be a strong acid? It means it really wants to donate its proton. It has a very strong, stable conjugate base. Really wants to donate proton. High Ka value. Dissociates completely. How does one calculate the volume and concentration of a titrated species? Na1 or N1, M1V1 equals N2V2 of the titrand. N1 is refers to the normality. What is the name of the structure of common oxyacids? You have phosphate, which is PO4 3 minus. We have sulfate, which is SO4 2 minus. We have borate, which is BO3 3 minus, and we have which one is it? Carbonate, sulfate, phosphate, chromate, chromate, CO4 2 minus. Okay, CO3 2 minus is carbonate, CO4 2 minus sulfate, PO4 3 minus is phosphate, BO3 3 minus is borate, CO4 2 minus is chromate. When an acid loses proton, does the proton just float around in solution? Typically we think it just floats around in solution freely, but it actually reacts with water to form hydronium. Of the three acid definitions, which one is the most general? Arrhenius is the most specific, then it goes Bronsted, then it goes Lewis. Bronsted-Lowry bases. Bronsted-Lowry bases are just... Bronsted-Lowry bases are bases that accept protons. Amphoteric means it can react as an acid or base. Water is amphoteric. Conjugate bases are it's when an acid reacts with something, and when the acid loses its proton, it becomes a conjugate base. For a weak base, titrate with a strong acid. You have a curve here. Weak base starts around pH 10 and then slowly decreases, and the pH or the pKa is typically above the pKa because you're titrating with a strong acid. Oh crap, oh well. Px is just negative log of x. Weak monoprotic acid with water, so HA plus H2O equals A minus plus H plus. HO plus. Buffer solutions is just a weak acid and its conjugate base. Weak acid and its conjugate base. I don't know what else to say. Equivalence point is the point where pH equals pKa. Equivalence point is the point at which the reaction is a half point, pH equals pKa. The equivalence point is a point at which the reaction between the titrant and titrant is completed. What do you name an acid from HA where A? So if it's single anion, you go hydroanionic acid. So hydrofluoric acid, hydrochloric acid, etc. Hydroanionic acid. Bronsted-Lowry donates protons. Acid-base problem, you treat them like equilibrium reactions, so use KEQ like normal. As pH goes down, acid strike will increase. Water will behave like an acid. We just have multiple equivalence points for polyvalent titrate curves. Each one represents a pKa. Polyprotic acids can dissociate more than once, so 1 mole of polyprotic acid would dissociate into more than 1 mole of proton. pH is negative log of H plus. What parameters define the strength of an acid or base? Ka and Kb. What is the name of the chlorate acids? We have chlorite, Hypochlorite is ClO minus. Chlorite is Cl2 minus. ClO3 minus is chlorate, and then ClO4 minus is hyperchlorate. Acid and bases, we have Arrhenius definition, Bronsted-Lowry, and Lewis definition. Weak monoprotic, so BOH plus H2O equals OH minus and HB. What is Lewis acid? Accepts electrons. Gram equivalent weight. It's the molar mass of the acid divided by how many protons it can give. Weak acid and bases have weak conjugates. Ka times Kb equals Kw, which is the water autoionization constant of 1 times 10 to the negative 14. Oh, it has to be the conjugate base, not just any base. What is a conjugate acid? Forms from the base when it gains a proton. How does water behave when it behaves with the base? What is the induction in terms of context of acids? It's the stabilization through resonance of the conjugate base. Stabler the conjugate base, the stronger the acid. How do you convert pH to pOH in solution? What is titration? Your basic titration is basically where you have this, like, you have the titrant over here, then you have the burette with a titrant, and then the titrant, you know the moles, and you know the concentration and the volume, while the titrant, you only know the volume, but you don't know the concentration. And you basically keep doing to N1 volume, no volume. Titration is a procedure used to determine the concentration of a known reactant in a solution. Titration is a procedure used to determine the concentration of known reactant in the solution. KW 1 times negative 14 at 25 degrees Celsius, ionization constant of water. So the appearance of strong acid and strong... Basically, it's going to look like a... linear line. Describe the appearance of a weak acid tritrate with a strong base. So weak acid starts around pH 2, and it will slowly increase and then jump up. Equivalent points is usually at a pH above above 7 because it's a strong base. How does titration work? The titrant is something you know the volume and concentration of. You add titrant to the titrand until the color changes with an indicator, and once you can calculate how many moles of titrant you added to determine how many moles are in the solution. Arrhenius bases are things that dissociate to OH minus. As it goes down. Arrhenius acids are donate protons, so they dissociate to protons. The equivalence point. When the number of equivalents of acids and bases are equal. Strong acids, high Ka value, dissociate completely. pH equals pKa plus log A over HA, or pOH equals pKb plus log B plus over HB. Basically, they use Le Chatelier's principle, and any changes in H plus or OH will be counteracted by the equilibrium of the buffer solution. How do you pick where the color change is within the pKa range you expect it to be? We have CO3 2 minus is carbonate, SO4 2 minus is sulfate, PO4 3 minus is phosphate, BO3 3 minus is borate, CrO4 3 minus is chromate. CrO4 2 minus, whatever. What is the equivalence point? The point where the titration is over, and the equivalence when there's equivalent acids and bases. Equivalence point. It's when the titration is over, basically. What is the reaction of a weak monoprotic acid? We have BOH condensing into OH minus and H plus. OH minus and B plus. How does one convert K? Ka times Kb of its conjugate base equals 1 times 10 to the negative 14, or Kw. Titration is using a titrant, which you know the moles and volume of, and the titrant is something you only know the volume of, but you don't know how many moles there is in there. Kw equals H3O plus times OH minus equals 1 times 10 to the negative 14 at 25 degrees Celsius. Strong acid base start off very low, then jumps up. pH, or the equivalence point, is equal to pH 7 because they neutralize each other completely. Titration by dumping titrant. The titrant is something you know the volume and concentration of, and the titrant is something you don't know the concentration of, the volume. So you keep dumping titrant into the titrant until you observe a color change with your indicator. From there, you can calculate how much volume of titrant you added to determine how many moles of reactant you had to begin with. In acid-base titration, when is the reaction completed? When there's equivalent amounts of acid and base. That was quick. All right, let's jump to OChem, Chapter 5. Other than being used as a leaving group, how are tosylates and methylates useful? You can use them to protect, like, alcohols. Or no, you can use them to protect, like, is it alcohols? And then you can convert them back to alcohols, or is it carbonyls? Yeah. You can protect alcohols. What are characters? Alcohol. High boiling point due to intermolecular forces, specifically hydrogen bonding. Hydroxyl groups are bad leaving groups. How do secondary alcohols interact with oxidizing agents? So secondary alcohols with oxidizing agents will always form a ketone. Ubiquinone is a biologically important quinone known as quinolism Q. Oxidized versions ubiquinone, reduced versions ubiquinol. What is a quinone? Product of oxidation of phenols. They are characterized by a ring system with carbonyls. Some quinones are aromatic, not all of them. So phenol converted it into a carbonyl. Aromatic ring. What is a tosylate? Tosylate is can be formed through using something called TosCl on an oxygen, adds a tos group to the O. How do primary alcohols interact with oxidizing agents? Basically, most of them will form carboxylic acids, except for PCC because it's a weak oxidizing agent where it will form aldehyde. How can you protect a carbonyl? Reduce it to an alcohol and add OTOS groups. Are susceptible to reduction. And so in reduction reactions where you don't want to lose a carbon, you need to protect it somehow. This is accomplished by reacting aldehydes and ketones with 2 equivalents of alcohol, 1 equivalent of alcohol to form acetyls or ketals. Carbonyls are susceptible to reduction. So in reduction reactions where you don't want to lose a carbon, you need to protect it somehow. This is accomplished by reacting aldehydes and ketones with 2 equivalents of alcohol, 1 equivalent of alcohol to form an acetyl. Reacting aldehydes or ketones with 2 equivalents of alcohol or 1 equivalent of a diol that form acetyl or ketal. Back. Treating with aqueous acid reduces it to deducted carbonyl. Okay. What is a mesylate? CSCl. It's a protecting group for oxygen. Using methyl sulfonyl chloride and on an alcohol in the presence of pyridine base to form OMS. Methyl sulfonyl chloride. Hydroxyquinones are just quinones with 1 or more hydroxyl group attached to it. Jones oxidation is where you're taking the carbonyl, or it's any general reaction that turns an alcohol into a carbonyl, I think. Very strong oxidation, CrO3, H2SO4, and acetone. A phenol is a aromatic ring with a hydroxyl group attached to it, pKa around 10. it's way more acidic because it can stabilize it. It's like the aromatic ring. How are alcohols commonly modified to make them a better leading group? Addition of better leading groups through like O-tos or tosylate and methylate. Ubiquinone is also known as coenzyme Q, important in the electron transport chain, specifically ETC, are involved in chains 1, 2, and 3. And ubiquinone is the oxidized form. Ubiquinol is the reduced form. Quinones are basically products of oxidation of phenol. So you take a phenol, you can oxidize it by chromating carbonyls into a quinone. How can you protect a carbonyl? You can react it with a diol to form an acetal or ketal, which looks like that, which makes it a better protecting group. And you can reduce it back to a carbonyl by reacting it with aqueous acid. Methylates are when you react a primary alcohol with methyl sulfonyl chloride, SOCH3MS or whatever, and you form basically a protecting group where it's called OMS. Hydroxyquinones are quinones, so with a hydroxy group attached to it. Jones reaction is reaction with alcohol with TR3-, H2SO4, and pyridine base to form a very strong oxidation reaction. And acetone. Close enough. A phenol is it's an aromatic ring with a hydroxy group attached to it, and it's more acidic than alcohol hydrogens because the conjugate base is stabilized by resonance structure with the aromatic ring. Cool. Let's jump to physics chapter 2. Okay. What is power? Power is just rate of energy per second, rate of energy transfer per second. Yeah. What is the basic unit of joules? Kilogram times meter squared over second squared. Nice. What are non-conservative forces? These are forces that don't release energy into, or no, that do release energy into the atmosphere, such as friction and air resistance. Heat line, sound, friction, air friction. What should one assign 0 when calculating? You can assign 0 anywhere when calculating gravitational potential energy. What are the two types of energy transfer? Heat energy and mechanical energy, which is work. What is work? Work equals mechanical energy transfer of one object to mechanical transfer of energy from one object to another. What should the change in total mechanical energy of an object be equal to when considering non-conservative forces? If you're considering non-conservative forces, there's no heat, so delta E is only equal to work. Work net. Work non-conservative forces equals delta KE. No. Work non-conservative equals delta E, which equals delta U plus delta K. What's the form of elastic potential energy? The delta U equals 1/2 kx squared. How does mechanical advantage work? Applying a short distance with lots of applying smaller force over long distance to produce something with more force over a short distance. What should the change in total mechanical energy be when you work conservative 0. How does one calculate obtuse graphing? PE U equals mgh. Power equals work over T or delta E over T. This is a formula to calculate an object's kinetic energy. Ke equals 1/2 mv squared. What is kinetic energy? Energy associated with motion. How does efficiency equals work out, work in, or load times load distance, effort times effort distance. Efficiency equals work out times work in over load times load distance, effort over effort distance. I also want to calculate power in terms. Power equals force for time, force per second. Power equals force times velocity cosine theta. Work equals force d cosine theta. I just want to call it work done by gases. Work equals P delta V. What is object's total mechanical energy? Delta E equals delta U plus delta K. What is the first law of thermodynamics? Energy cannot be created nor destroyed, transfer from one form to another. Conservative forces are forces that don't dissipate energy into the environment. They conserve the energy. This is gravitational energy and electrostatics. What do we basically work? So we have work non-conservative equals delta E, or work non-conservative equals delta E. Work conservative equals delta E equals 0. Work equals P force D cosine theta. Work equals P delta V. Work net equals delta K. What is energy? Capacity to do work. What is potential energy? Energy associated with position in the system. Mechanical advantage. F out over F in. Mechanical advantage equals F out over F in. How does one calculate work done by gases using the P? Take the area to find the work. What is the work energy theorem? Work net equals delta KE. What are forces that dissipate energy into the surrounding via light, heat, and sound? Friction, air resistance are examples. Work, capacity, transfer mechanical energy from one thing to another. What should the change in total mechanical energy of object be equal to when conserving? So work non-conservative forces equals delta E, which equals delta KE plus delta U. What should change work conservative equals 0, so delta E equals 0, delta KE equals minus delta U. I always want to call it power in terms of work. Power equals work over time. Delta E over time. It is conservative. Or work equals delta E, work non-conservative. What is efficiency equals work in over work out. Load times load distance, effort times effort distance. Work out over work in. Power in terms of force, power equals force times V cosine theta. What are 3 ways to calculate work? So work net equals delta KE. Work equals P delta V, and work equals force D cosine theta. Energy is the capacity to do work. Mechanical advantage is force out over force in. Work energy theorem states that work net equals delta KE. Power in terms of work, power equals work over time, or delta E over time. Efficiency equals work out over work in, load times load distance, effort times effort distance. Cool. Nice.